Welcome to 7.1 Factoring Refresher. So today we are going to factor the sum and difference of cubes, which is something that is new, but we're also going to review previously learned methods for factoring. So with sum and difference of cubes, we do have something that helps us remember the signs for factoring, and we call it SOAP. So the first sign that we use will be the same. Then we're going to use the opposite sign, and the last sign is always going to be positive. So for sum and difference of cubes, they have a formula that looks exactly the same. The only difference is the signs. So for sum, I have a cubed plus b cubed because it's a sum, and I have a plus b, so the same sign, a squared minus the opposite sign, a times b, and the last sign is always positive, plus b squared. Now, the difference of cubes formula is going to look exactly the same, except for I have subtraction, same sign, opposite signs, minus, plus, and my last sign is always positive. So we do have the same terms. The only difference between the two will be the signs. So let's go ahead and look at number one. The first thing that you're going to want to do with problems like these, especially because they're similar to what we did with difference of squares, is you're going to want to rewrite it so that you can kind of identify what is the a term and what is the b term. So I'm going to rewrite x cubed minus 1 as x cubed minus 1 cubed. Now, yes, it is exactly the same, but it's really important that you kind of see what is the base of this exponent. So I know my a is x and my b is 1, and I know I'm doing the difference. So I'm going to use this second formula to factor. So I have x minus 1 times x squared plus x times 1 plus 1 squared. And from here, it's just going to be some simplification. The first term I can't do anything with, so I'm going to leave it alone. X squared is x squared. X times 1 is just x, and 1 squared is 1. And this is my final factored form. Cannot factor any more than this. Now, number two complicates things a little bit because I don't have a very obvious base. So you have to think, well, what's the cube root of 8? That's going to be 2. Cube root of x cubed is x, and cube root of 27 is 3. So my bases are going to be 2x and 3. Again, I'm doing a difference, so I'm going to use this second formula, plug in what I know, 2x minus 3, 2x squared, plus 2x times 3, plus 3 squared. Parentheses are really important, especially when you have two terms in your base. So my answer is going to look like this. Again, first term, nothing special. What you have to be careful of is this squared is going to distribute to the 2 and to the x, giving me 4x squared. Plus 3 times 2x is 6x, 3 squared is 9. Again, this is as simplified as it gets. You do not have to go any further because you really can't. Now, for number three, we're now working with sum of cubes. But something you should always be checking for is, do I have a GCF? And for this problem, I do have a greatest common factor. I have a greatest common factor of 2. So I pull a 2 out, and that leaves me with x cubed plus 125. Well, x cubed is pretty obvious, but 125 is the same thing as 5 cubed. Now, I do have some of cubes, so I am going to use a different signs than I have in previous examples, but I'm going to fill in what I know. Same sign, opposite sign, always positive. Now, doing a little more simplification, 2x plus 5, x squared minus 5x plus 5 squared is 25. Do not forget about your GCF. That is a part of your final answer. For number 4, I am going to have to do a little bit of rewriting to figure out what my bases are. The 1 is pretty easy. Base is 1, 1 cubed. The 64x cubed, always think about what's the cube root of 64? 4. What's the cube root of x cubed? x. So my base is 4x raised to the power of 3. I'm doing difference again, so I'm going to fill in what I know. 1 minus 4x, 1 squared, plus 1 times 4x, plus 4x squared. You have to be careful because I have 2 terms in this base, so this squared is going to get distributed to both of them, giving me my final answer of 1 minus 4x times 1 plus 4x plus 16x squared. Now, this was all of the new factoring material. Now we're going to go on and review what we've learned previously. For number 5, I am doing just general factoring, not factoring. Always check for a GCF, and this problem doesn't have a GCF, and it does have a equal to 1, meaning that I can use the shortcut. So the first thing I'm going to do is I'm going to go in and try to see what multiplies, because technically when you're factoring, you're doing A times C. So 1 times negative 12 is just negative 12. What multiplies to be negative 12? What adds to be 1? So those two factors are going to be negative 3 and positive 4. The nice thing about when A is equal to 1 is that these two factors become your final factored form, x minus 3, x plus 4. Now, this number 6 does have a GCF, has a GCF of 4, so I pull it out of every single term. So that leaves me with 4x squared plus 2x plus 1. Now, again, I have A is equal to 1, so I can use the shortcut. A times C is 1. My B term is 2. So what multiplies to be 1 adds to be 2, positive 1 and positive 1. So do not forget about your GCF. My final answer is 4x plus 1, x plus 1. The hope is that you always have A is equal to 1, but one thing you have to be careful of is you have to remember we can only use the shortcut when A is equal to 1. When A doesn't equal 1, meaning that first term attached to the squared, when it's not 1, we have to go the long way and split the middle term. So to review that, let's go ahead and look at number 7. So I have no GCF. 2, 5, and 3 have nothing in common. And A is currently equal to 2. A is not equal to 1. I'm going to go through the similar process that I would finding my normal factors. A times C, 2 times 3 is 6, and my B term is 5. So I have to think, what multiplies to be 6 and adds to be 5? Those two factors end up being plus 2 and plus 3. So what I do is I take this 5x term and I split it into plus 2x plus 3x. Now this creates 4-term grouping. So I'm going to group my first 2 terms together and my last 2 terms together. And what I'm looking for now is what's the GCF of this first group? Well, 2x squared and 2x have a 2x in common, leaving me with x plus 1. 3x and 3 have a 3 in common, leaving me with x plus 1. Now, both of these terms, this term and this term, now have a GCF of parentheses x plus 1. So I pull that out to the front, and that leaves me with x plus 1 times 2x plus 3. Now, looking at number 8, I do notice that I have a GCF. I'm going to pull out my 3 first, and then magically, my factoring problem has turned into an A equals 1 problem. What multiplies to be negative 3 adds to be positive 2, negative 1 and positive 3. So these two are going to be my factors. Now, I do want to let you know, if you were to take this and do the long method of splitting the middle, you'd still come to the correct answer. You may have to pull out the GCF of 3 at some point because that is required, but it's not incorrect to go the long way every single time. It's just time consuming. So For number 9, this is going to be a problem where I have a GCF. Now, it's not a common one that we're used to seeing, but every single term has an x in common. So I'm going to pull an x out to the front, leaving me with x squared plus 9x plus 14. A is equal to 1, so a times c is 14, b is 9, plus 2 and plus 7 multiply to be 14, add to be 9. My factored form is x plus 2, x plus 7. Now, sometimes you are fortunate and you're given 4 terms. Don't get frightened by one of these problems. It's just as easy as going through the steps of splitting the middle. I'm just going to group my first 2 terms together and my last 2 terms together. First group, the GCF is going to be x squared, leaving me with x minus 7. Second group, the GCF could either be positive 9 or negative 9. Now, I chose negative 9, and the reason why is in order for us to continue with our factoring steps, we want these parentheses to match. So in order for my 2 parentheses to match, I had to pull a negative 9 out. If I had only pulled out a positive 9, this would be negative x plus 7, which would not match my other parentheses. So that's kind of the process for how you decide what GCF sign to use. So that gives me x minus 7, x squared minus 9. And we're going to come back to this problem in just a second. We're going to go ahead and take a look at difference of squares before we finish this problem out. So difference of squares we have talked about previously. Remember, I am taking a squared minus b squared, and it's equivalent to a plus b, a minus b. And you cannot factor sum of squares. So for cubes, we can do difference and we can do sum. For squares, we can only do difference. So 11, we are going to identify our a and b. Square root of 4 is 2. Square root of x squared is x. Square root of 121 is 11. So that's going to give me a base of 2x for a and a base of 11 for b. So I'm just going to use the formula. 2x plus 11, 2x minus 11. Now, number 12, I do have a GCF of 2. That gives me 2 times x squared plus 25. Well, we just said you cannot factor sum of squares. So, unfortunately, or fortunately, if you like, we are done. The final factored form is 2x squared plus 25. And yes, we did do factoring. Remember that GCF is factoring, so we would not call this problem prime. So now that we've kind of reviewed difference of squares, let's go ahead and go back to number 10. So x minus 7, cool, we're going to leave it alone. X squared minus 9, I take some issue with because we can factor this more. And if you can factor more, you should. So let's go ahead and rewrite it in the form that we're used to when we are doing difference of squares. I have x squared minus 3 squared because 3 squared is equivalent to 9. So I can use my difference of squares formula to say x minus 7, x plus 3, x minus 3.